Hello, welcome to High Quality Podcast Action, where two really cool sciencey engineering dudes discuss sciencey engineering stuff. I happen to be named Nick. He happens to be named John. Was it? You said?
Yes,
You know,
that's
you,
correct.
you think I'd remember that since it's been since what, seventh grade?
Yeah, yeah, we're it's not like we're friends or anything.
No. So last week we had an all politics episode. So today we're gonna make up.
Unfortunately.
Right. So today we're going to make up for that by not talking about politics at all. This is all sciencey stuff. So if that's not what you're looking for, find some other podcast. Or, go back and listen to our political ones. Because there's plenty of
Yeah.
those too.
There was enough politics in the last podcast that I think that could tide over most people for a couple weeks.
And there's nothing that I think really that I run a rant at. So it worked out perfectly in a way.
Yeah, I think we're all politicsed out, really.
Yeah,
Everyone is
for now.
from the last few weeks leading up to and after the midterm elections in the US.
For now. So
For now. Yeah.
Where should we start here?
Well,
Of course, your alcoholic beverage is also a good starting
yes,
point. Okay.
we can start there.
Okay, let's start there. What are you drinking today?
Start things off slow and smooth.
Mm,
Um,
some jazz
Today is
music.
not a beer. Today is a cider.
Is that allowed? Are
Yes.
we allowing that? Is
Yes.
that against the rules? Okay.
I'm allowing it.
Okay.
It's been allowed. So, this cider is a local, by local I mean local to New York State cider, made in, I believe, Sydney, New York. Not sure where that is, but it's in New York.
Oh, I got you, fam. I'm looking it up right now.
Please don't say that.
Oh, don't worry, John. I am
There you
looking
go.
up the location of a one Sydney, New York.
Thank you. Can't say I'm the biggest fan of that phrase, but in any event,
It is literally in the middle of nowhere.
kind of like where I'm at.
It's like sort of close to Interstate 88, like smack dab between I don't even know Poughkeepsie and Ithaca. I don't know how to describe it.
Sure.
It's in the middle of nowhere. It's not important.
It's one of those towns.
Yeah, it's pretty small.
That works. And then essentially what I figured. Anyway, to the cider. This is a cider by the company out of middle of nowhere, Sydney, New York, by the name of excuse me. By the name of Gravity Ciders. And the name of this particular cider is the Ostruck Hometown Homicider. Is interestingly named. I'm not entirely sure why. Probably because it's partly Halloween themed, and only partly because it involves pumpkins in the cider.
Let me say
Or-
real quick, I like the name Gravity Apple Cider.
It is good. It's a good name.
It is decent.
So the cider itself is a spiced pumpkin cider that has also been aged in bourbon barrels. So it has qualities of both a kind of spiced apple pie with a little bit of pumpkin spice in there, as well as being nicely orange, and has a bit of vanilla and bourbon woodiness to it. It's a little on the sweet side for ciders if you're into that. Me personally, it's not too sweet, but teetering on the brink of being too sweet. So I gave it a 3.5 out of 5. It's reasonable. You can drink it pretty easily, and it's not highly alcoholic or anything like that.
Has a
But
sweet
it
name.
has a couple things that make it a little more unique in terms of ciders, how they come and go.
Well, good. It's good. Good stuff.
Mm-hmm.
I think to prevent any further suspense, since I've been putting this off for a very long time.
Okay.
Here now, a little story about maybe where the beginning of life happened. Or at least, kind of very, very early stages. And I mean early. I'm talking like on a molecular level. We're not even to cellular level. Molecular, okay? So hold your pants on.
Do tell.
So, and I'm going to say a lot of chemistry nomenclature. So I'll do my best to define stuff that, I think that you won't know. But at the same time, you may not know that I thought that you knew, but you didn't know. So take that for what you will.
Extremely vague.
Well, it's...
But all right.
I'm doing my best here. Okay.
We'll roll with it.
In the molecular dance that gave birth to life on Earth, RNA is the central player. But the origins of RNA have remained a mystery. So, RNA can store genetic information, as DNA does, and speed chemical reactions as proteins do. You get the best of both worlds. Now, a team of researchers has shown, for the first time, that a set of simple starting materials, likely present on early Earth, can produce all 4 of RNA's chemical building blocks: adenine, cytosine, guanine, and uracil. Now, all 4 of those have previously been recreated. 2009 chemists led by John Sutherland at the University of Cambridge devised a set of 5 compounds likely present on early Earth that could give rise to cytosine and uracil. Those two, specifically those two, because of their unique pyrimidine organic chemical structure. So there's a slight difference between their structures, but basically they look the same. If you looked at a diagram, they look really similar. Anyway, 2 years ago, researchers led by chemist Thomas Carell at Ludwig Maximilian University in Munich reported that his team had an equally easy way to form the other 2 RNA molecules, adenine and guanine. Those building blocks are purines. So these 2 sets of chemical reactions are different enough that it is not clear how the conditions for making both pairs of building blocks could have occurred in the same place at the same time. So in other words, maybe one part of Earth reproduced cytosine and uracil, and another part was ideal for producing, adenine and guanine. So how did they meet? Well, what if you had conditions that could have created both? So Dr. Carell, back in Munich, says he may just have the answer about the origins of the RNA building blocks. On Tuesday of many weeks ago, at the Origins of Life workshop, he reported that he and his colleagues came up with a simple set of reactions they believe could have given rise to all 4 RNA bases. And it starts with only 6 molecular building blocks. That's it. Just 6. Oxygen, nitrogen, methane, CH4, ammonia, NH3, and water, H2O, and hydrogen cyanide, HCN. All of which would have been present on early Earth. Other research groups had shown that these molecules could react to form somewhat more complex compounds than ones that Carell had used. So to make pyrimidines, Carell started with compounds called, cyanoacetylene, which is chemical formula C3HN, and
Love those chemical terms.
yeah, they're totally not difficult or similar sounding.
Always ridiculous.
and hydroxylamine H3NO, which react to form compounds called isooxazoles. Someone's going to rail on me for my pronunciation, I just know it, but I'm trying, okay? These in turn react with other simple molecules, if you want to call them that, such as urea, CH4N2O, to form compounds that then react with a sugar called ribose, which your cells have, C5H10O5, to make one last set of intermediate compounds. Finally, in the presence of sulfur-containing compounds called thiols and trace amounts of iron or nickel salts, these intermediate compounds transform into the pyrimidines cytosine and uracil. As a bonus, this last reaction is triggered when the metals in the salts harbor extra positive charges, which is precisely what occurs in the final step in a similar molecular cascade that produces the purines, adenine and guanine. Even better, the step that leads to all four nucleotides working in one pot, offering for the first time a plausible explanation of how all of RNA's building blocks could have arisen side by side. I don't have more details about the conditions these reactions require to take place. However, someone else of a greater mindset does. Stephen Benner, chemist at the Foundation of Applied Molecular Evolution in Alachua, Florida, said, "It looks pretty good to me. The process provides a simple way to produce all four bases under conditions consistent with those believed on early Earth. The process does not solve all of RNA's mysteries, though. We still don't know how the four RNA building blocks linked into long chains to form genetic material and carry out chemical reactions. However, making RNA under conditions like those present on early Earth now appears within reach." The organic chemistry behind RNA and DNA building blocks is pretty interesting, and I thought it would be interesting to learn a little more organic chemistry about RNA building blocks, but it's so visual intensive, it's hard to explain anything through a podcast, and it would just be a whole lot of numbers and big words, and you'd probably be even more bored than you may already be so far.
If you want to learn organic chemistry, kids, go to college.
Yes, indeed. So unfortunately, I couldn't make it as clear, and some people probably would not have found it as interesting as I did. But yeah, so that's pretty cool, though, that we at least can see that the fundamental building blocks behind RNA, and which would subsequently lead to DNA, are finally within our grasp. So maybe soon we'll kind of get a better understanding of where things went from there.
Always interesting to delve deeper into the origins of life itself, or life as we know it.
Indeed.
Not only would that be beneficial for understanding life on Earth, but I would assume it would have some ramifications for extraterrestrial life as well.
Oh, indeed. If we can see, I know obviously it took a very long time for, more complex multicellular life to happen, but if we can see some similar conditions to what early Earth was like out in space and other exoplanets, then who knows, maybe we can see life forming at a distance.
That's already one way that scientists have used to identify some properties of exoplanets is by examining whether there's generation of hydrogen or carbon dioxide or those kind of things that you would see from either carbon-based life forms or even with plants having oxygen production within an atmosphere is a dead giveaway for there being something going on, not necessarily with plants or animals like we might think of them, but geothermal activity where you have volcanic vents, undersea volcanic vents, or even surface volcanic activity producing these complex organic compounds or base organic compounds.
So I talked about, chemistry and molecules, and those are all made of particles.
They are.
I was wondering, do you have anything as far as particles go for this week?
I do. When don't I? Would be a
I
better
don't I
question.
don't know what It's not it's not like you do this for a living or anything.
Nope,
No,
not at all.
totally
I
not.
don't. I don't know a damn thing about
I,
particle accelerators or elementary particle physics.
you would think someone like me would report more on medical stuff, but no,
No.
no. I do have something more medical, but that's later on.
And I have something about particle accelerators. So we're
Well,
both liars.
yes. So anyway,
In any event, particle accelerator being built in China or planned to be built in China. The Chinese government has recently revealed a little bit more about the design of a extremely large particle accelerator, larger than the Large Hadron Collider at CERN,
whoa.
currently the world's largest particle accelerator. The Chinese Circular Electron Positron Collider released some reports regarding their proposed design for this collider that had originally surfaced in 2012 when the suggestion to build a larger particle accelerator, or what is more colloquially known as a Higgs factory, which, if you'll remember back to 2012 or thereabouts, the discovery of the Higgs boson, or the quote unquote God particle, even though you shouldn't call it that. It's just a particle that happens to be the progenitor of the Higgs field, which is the electrodynamic field that gives all particles their mass, or imbues mass to all of the other fundamental particles within the standard model of physics that we know today.
I am your Lord and God particle. Kneel before me.
My name is Higgs.
Higgs
Higgs boson. Or boson. Higgs boson. James
Bison.
Bond.
Higgs Bison.
Yes. So, the Higgs factory, as it's known, since the energy of the Higgs, or the mass of the Higgs, is only around 125 gigaelectron volts, which is comparatively low to other elementary particles. The use of an electron positron collider as opposed to a hadron collider that the Large Hadron Collider gets its namesake from, that is, hadrons being protons, heavier particles than electrons. The electron positron collider that the Chinese are planning to build could be used to find millions of Higgs events, or create millions of Higgs events to study more closely the phenomena surrounding the decay of particles into the Higgs and the Higgs itself. This is a bit easier using an electron positron collider because of the low mass of the Higgs, and would also be able to be converted over to a proton-proton or a hadron collider at some point in the distant future, probably 30, closer to 40 or 50 years down the road. Now, the overall size of this particular accelerator could be on the order of, instead of CERN's 27 kilometers, the the particle collider in China could have something along the order of 62 miles, which is a bit ridiculous. To give you an idea of the size of that, the whole of this particle accelerator in China would engulf or surround the entire island of Manhattan if it were placed around New York City.
Yikes.
Not a small endeavor by any means.
I don't know if I could live anywhere.
CERN's particle accelerator was previously housing, or the tunnel for the accelerator was previously housing another particle accelerator. So they kind of had a leg up on construction for that and really only had to change around all of the internals in a 27-kilometer tunnel, but a little more to do in terms of construction with this particular accelerator.
I don't know if I could live in a place that, had a particle accelerator running around it. It just seems somewhat ominous.
Maybe a little bit for certain people, but you have to remember that these particle accelerators are very controlled environments that, while they may generate small black holes,
which is badass,
they don't produce anything that is remotely detrimental to any of the surrounding area. Certainly less so than, say, a coal-fired power plant being built somewhere.
Do you like meteor showers?
I do.
Well, this Saturday will be the prime time for you to view the Leonid meteor shower. I know it's early to be wishing for stuff, but shooting stars are en route. And funny thing, this has always occurred in the middle of November. That's why this has a name to it.
It's a regularly occurring yearly meteor shower.
Yeah, an average of about 15 meteors per hour strike across the sky during the peak meteor dropping hours. The problem, it's going to be competing with a waxing gibbous moon. So the best time to watch is after the moon has set and before dawn. When you're usually asleep.
Yeah, like 4 a.m.
Yeah, so unless you feel like getting up early, probably not going to see a whole lot. But yeah, if you've ever seen any sort of meteor shower, depending on where you are, it's cool to see, but it's not like, it doesn't look like a spaceship landing or anything. Like, you'll probably see a trail and some object for a brief second, and then it'll burn up. At least that's been my experience.
That's generally how meteor showers go.
Right. That's why you don't see a whole lot of objects staying in the air for long periods of time. They're very small. They're not like Armageddon, humongous Texas-sized asteroids.
Thankfully not.
They're small meteors. They get burned up in the atmosphere, but it looks really cool. Okay? So if you're into that stuff, get up early Saturday and grab yourself some coffee, sit out on the deck, and watch the meteors.
Freeze your ass off, depending on where you're
at. And watch the meteors shower down upon you.
Yes. As the Earth moves through the tail of a comet far, far away.
Anyway, so
that's how meteor showers happen. Moving through a debris trail from a comet.
It's true.
Fun fact.
They don't just travel here to catch a Cowboys game. They have no choice.
Something with that kind of regularity would not be possible.
Definitely not.
By that means.
So,
what else you got?
One thing that maybe some people have always thought about, had a shower thought about. Why does your mom's immune system, when you were developing in her uterus, why did her body not attack the shit out of you? Because you are foreign material. You fucking fetus piece of shit. What are you doing? That is not your body. Okay?
Sure. That's a shower thought.
Yeah.
I guess.
Well, if Like, the female reproductive system has all these defenses to prevent sperm from reaching an egg, which is kind of funny when you think
Sure.
about it. Um,
Can't say
that's
I've ever really thought about my mom's immune system while taking a shower,
okay.
but
That is not at all what I meant. I don't mean
you know,
when I said that. I didn't mean like whoever thinks that thinks about their mom. No, I
sure,
meant pregnancy
sure.
in general.
Anyway, moving on.
God, you had to go and make shit weird again.
Yeah, you know.
You know, go pray to your god, Higgs Bison. Anyway, well, this is one of pregnancy's most baffling aspects. Has been, why does mommy's immune system not destroy the developing fetus? It is, after all, foreign material. Some could call it an invading microbe. Well, now researchers have captured the intricate molecular negotiations that help keep both fetus and mom safe until the baby is delivered. I wanted to write this in a children's book-like manner, but I have a job. And that is not conducive with doing such. So you'll just have to deal with the normal, lengthy, huge, scary science words. The complexity is rather stunning, just to put it lightly. Because understanding this communication could eventually help reduce miscarriages and other complications of pregnancy. So once again, you can have a positive effect on something that you may not initially think of as having a very important effect. So these complications during pregnancy often have roots in the earliest days of pregnancy, when the embryo starts to move into the decidua, which is the lining of the uterus. The maternal-fetal interface is not well understood still, but is a crucial part for a successful pregnancy. So, doctors have decided to examine the gene activity of single cells from the mother and the fetus during that initial period. They studied 70,000 white blood cells and cells from the placental and decidual tissues of women who terminated their pregnancies between 6 weeks and 14 weeks of gestation. Using single-cell transcriptomic technology, they assessed each cell's gene activity, getting a readout of which proteins were present, and determined what each cell was. They identified 35 types of cells. Some new, some already known. How about that? They discovered new tissue, including various embryonic cells that invade, there's that word again, the mother's tissue, and help trigger the formation of blood vessel connections between mother and fetus. The researchers also detected multiple kinds of immune cells, including several types of so-called natural killer cells. And these natural killer cells normally destroy infected cells and tumor cells. Then, they combed existing databases of protein interactions to determine which of these cells were interacting with each other based on those protein links. So in a way, if you want to think of it as like a murder scene, right? How do they catch the person who's connected to the murder scene? Maybe they have gun residue, or they left some sample of DNA at the crime scene. Same kind of thing here. They're finding the link between those cells to kind of determine what cells are interacting with one another during this period of gestation. So the invading embryonic cells stimulated mother cells to make some immune cells that reined in immune responses. This group of researchers also realized that at least some of mother's natural killer cells were peacekeepers, not warriors, preventing other immune cells from attacking the fetus and producing chemicals that promoted fetal growth and blood vessel connections. So I guess calling those natural killer cells is somewhat inaccurate in this case. They're not They were fighters, are now lovers. And these natural killer cells are controlled in part by certain cells in the decidua called stromal cells. And we can now see in detail how they communicate with each other. And the results also reveal multiple layers of regulation of immunity that were not previously appreciated. And many more interactions remain to be explored. And to that end, researchers have established an online database to help other researchers do just that. So, the moral of the story is natural killer cells are not always out for blood.
Sometimes they're out for children.
They're watching out for fetuses. That's right.
So, further solidifying the children are a cancer type of.
Well, if they were cancer, then those cells would be attacking it.
Sure.
Yes. But I mean, if the fetus isn't born, I'm pretty sure it could probably turn into cancer, or at minimum probably kill the mom. Anyway, let's not talk about that kind of stuff.
No, it's good that it doesn't happen, and
right.
Don't need to get into overly depressing anything.
No, so let's ignore that and move right along.
So on another space-related note, the more uplifting article or
uplifting
event.
Talking about space.
pun intended. NASA is set to broadcast their landing of a Mars lander, not a rover. Not a rover this time, just a lander.
It will not be moving, I think.
No.
It's just kind of there.
But it will be landing on Mars, which is an event in and of itself. This will be happening on November 26th, a Monday. So maybe not able to catch it on TV. I'm sure NASA will have a webcast, maybe even on Twitch. I don't know. They have some sporadic activity that goes on there, but I would assume it would be a little more official than that. In any event, the InSight lander, or Interior Exploration Using Seismic Investigations, Geodesy, and Heat Transport, is what InSight stands for, because we all know how much NASA loves ridiculously complicated acronyms.
And you know what I notice is they cheat on some of those acronyms. Like they'll use multiple letters from the same word. Like if something's inter something like that, they'll use the I in inter and then the first letter of whatever the other connecting word is. You can't do that. That is cheating.
In this case, they're using the IN in interior, skipping over exploration completely, then using seismic investigations, geodesy, and heat transport.
Cheaty McCheatertons.
InSight. They are very creative when it comes to their acronyms.
Now, what will InSight be doing on Mars?
InSight?
Having a big orgy with the other robots?
No. Although it is close to, I believe it will be close to the location of Curiosity, the rover Curiosity, and that's about the closest that it'll be to a mobile rover on the surface of Mars. But if the name wasn't a minor giveaway for what the lander will be doing, it's equipped with a seismometer and another instrument with a heat probe that will measure heat transfer and seismic activity on the red planet. It will try to determine some of the geothermal and geodesy, I guess, would be the proper name for it, since it's in the actual name of the lander. But it's going to be looking for some interesting activity through the interior of Mars, as opposed to just on the surface, which is the primary function of all of the landers and rovers that we have sent to Mars thus far. There has been some seismic investigation on the red planet in the past, but nothing to this scale or with this particular intent being the main focus of the mission. Usually the other landers or rovers were equipped with some minor seismographic equipment, but nothing on this order. So we will see what will become of this particular lander. And just as a further note, there's another NASA craft that will be landing in 2020 on the red planet, the ExoMars rover. It will be looking for signs of life and will be another mobile platform on the red planet, as we have come close to losing a couple of the rovers, Curiosity in particular, most recently, due to some complications and just the nature of having a extended mission on a completely alien planet to our own that has massive planet-wide dust storms and things that can completely block the transmission of solar power to the solar panels that all of these things run off of.
And also just the wear from, on the wheels too, because not all the rovers have the same design.
Nope.
Of course, I forget the stinking names, but the most recent rover didn't have those mesh wheels that you're probably familiar with. They had these aluminum alloy wheels that had very wide ridges in them. And they ran into an issue where one of them in the front was getting punctured a lot. And to help things wear more evenly, they had the robot just turn its body around so the back wheels are now front and vice versa.
Yeah. It's a consistent issue that NASA has been investigating through all of their rover designs, how to best optimize the wheels on rovers. And as a curious fact, there's a new design that I believe might be used on the ExoMars rover. I'd have to look into that a little bit more, but the idea being, instead of using the comparatively thin aluminum wheels that are on Curiosity, the intent would be to use a compliant mesh material similar to what you may be familiar with on the Apollo lunar lander, or lunar rover, excuse me, way back in the 60s and 70s. 70s specifically it would have been, as it was only on the last 3 or 4 Apollo missions, 15, 16, 17, and maybe 14. But the specific interest of these new wheels is the fact that a shape memory alloy will be used in the construction of them, or is planned to be used in the construction of them. So that essentially is a woven mesh metal tire that can have compliancy and spring back to its original shape without any long-term detrimental denting or getting ripped apart like the current wheels on Curiosity and other rovers have gone through driving across the rocky surface of the red planet.
That is so cool.
Some fun engineering ingenuity for you.
I like the Curiosity rover. I think that was the first one to actually take color pictures.
Maybe?
I might be wrong about that, but
I feel like the majority of color pictures that we see from Mars are color corrected by post-processing, not necessarily by the rovers themselves. Just because it's a little more weight to put a pure color photograph camera on a rover than it would be to just put a black and white and use image processing software afterward. But I could be wrong.
Either way, See, this is why I don't design probes. I do what I do. Or rovers.
We have both have our areas of interest.
Indeed. But I like seeing the physical pictures of whatever planet they're, exploring the surface of or have passed by, because that tells you, with one of the most important senses to us, our eyes, that, we might not be there physically, but in a way we are there. We've built something that has physically taken a visual specimen and sent it back to us. And I think seeing the surface of Mars from these, of course now we have pretty high resolution cameras, is really cool. Despite, despite the setting being somewhat blah, and just being nothing but, dust and rock, that's another planet that is really damn far away. So it's pretty darn cool to see things like that.
Yep.
Anyway,
it's very cool. It's
so
an understated way of
oh yeah,
of saying that, but I would definitely agree, and would someday love to see humans set foot on Mars, which, if Elon Musk has anything to say about it, will happen in the not so distant future.
I volunteer as tribute.
I wouldn't mind going to space. Put me on a rocket. Strap me in.
Hell, what else is to do here? Or record a podcast every week?
Yeah, it's pretty lame.
Boring. What do I want to go to now? Well, I really have only one other thing. And I'll start off by asking you some trivia, if you're down to play.
Good. My favorite segment.
Okay. No looking this up.
Okay.
Just do your best. Can you name the 7 SI base units?
The kilogram
It's 1.
is 1. The meter.
Meter.
There's 7.
Yes.
Kilogram, meter. Is it Kelvin and Celsius are not technically base units, are they?
Kelvin is the temperature
Okay.
base unit.
That's what I thought, but anyway, thinking in measurable quantities or physical quantities, as it were. Time, second.
Yes.
Let's see.
The 3 more I think most people might struggle with as well.
Yeah. So the electrical would be amps
Amps, yep.
or ampere,
Ampere,
whatever
amps, whatever. Same
proper
thing.
name. Yeah. Let's see. Chemical.
You're looking this
molar?
up, aren't you? You piece of shit.
No. I'm running through the. How dare you? How dare you
I
accuse me?
can't believe you've done this.
I can't believe. It's,
Okay, yeah, mole. Mole's correct. We got
moles.
One more.
Um. It's not watts
Nope.
because yeah. I don't know. I don't know the last one.
The last one is for luminous intensity, the candela.
Yeah, nope. Wouldn't have thought of that.
Nope. Well, one of these 7 is having its definition changed in the very near future.
Which one?
That would be the kilogram. Because the kilogram has a very unique property that these other 6 do not have.
And that is?
Well, it's measured kind of arbitrarily.
This is true.
So, to go through the other 6 and what they're based on. Distance, the meter, is the distance traveled by light in a vacuum for 1/300 millionth of a second. A second
Very
is
small amount of time.
yes. The second is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of cesium-133 atoms at 0 Kelvin. This is how the SI I don't know what to call it, booklet that I have here. That's how they define it. Okay.
The standard.
Standard.
Yeah.
Anyway, the ampere is the constant current which, if maintained in two straight parallel conductors of infinite length, are negligible circular cross-section and placed 1 meter apart in a vacuum, would produce between these conductors a force equal to 2 times 10 to the negative 7th newtons per meter of length. Even I read that and I was a little perplexed by that, so I can only imagine what you must think listening to this. Essentially, it's saying so you have an infinitely long length of wire, its cross section doesn't matter, and the distance between them is 1 meter, and they're in a vacuum. Ampere is the current produced by those two parallel wires between a conductor of a force that they gave per meter length of that wire. I hope that helped.
Basically, everything's made up and the points don't matter.
Well, I mean, it does matter.
Whose line is it anyway?
These do matter. Remember, stuff's not just made up in science. Gosh.
It's a joke.
What was your favorite Whose Line game?
That's a good question. I do enjoy scenes from a hat.
I always like props.
Yes, that was my next one, was props.
Because I don't know where they get some of those.
I feel like they probably just had interns go out and buy weird shit from prop or costume stores within the vicinity of the recording studio.
Wouldn't surprise me. Anyway, Kelvin is 1/273.16th of the thermodynamic temperature of the triple point of water.
Mm-hmm.
Triple point being the point at which water is the point where on a chart of pressure and what's the other axis? It's not temperature. Anyway, the point is a triple point is a point at which water can exist as all three states of matter:
solid, liquid, and gas.
Yep.
Yeah.
So 1/273rd of that. Mm-hmm. So in other words, cold as fuck.
So temperature and pressure for that.
It is temperature. Okay.
Graph.
I thought so, but I'm like, no, they can't define the temperature with temperature, can they? They did.
I mean, they can have a 2-temperature graph, but not in this case.
No.
Thermodynamics.
The mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilograms of carbon-12. And the candela has an odd history to it, but this is what they went with. The luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 5.4 times 10 to the 14th hertz. And that has a radiant intensity in that direction of 1/683rd watt per steradian. Now, both old and new definitions of the candela are approximately the luminous intensity of a whale blubber candle burning modestly bright, or what they called in the 19th century candle power.
So
funny
do
stuff.
we keep on hand whale blubber candles?
No, it's just an interesting fact that I threw in there.
Yeah, the history of these things is strange and curious.
Oh yeah, this is kind of why they have this standardized method to all these base units is that these are all based on something that doesn't change, you know? The hertz is not going to change. Mass of something doesn't change. None of this stuff is something that's physically going to ever change in the universe right now, based to a best of our knowledge. The kilogram is not defined in such a way right now. It is the mass of a small, squat cylinder, about 47 cubic centimeters of platinum iridium alloy, kept in the Pavillon de Breteuil, France. Also in practice, any of numerous official replicas of that prototype. To that definition, we say bye-bye. Say goodbye to the kilogram. Well, that definition of the kilogram. The kilogram itself isn't going anywhere. We're still using that.
Imperial form is taking over the SI units.
That's right.
Everyone's going to be using inches and pounds.
Imperial form's freaking goofy. I should have wrote down for comparison how we define stuff, because it is also just like so arbitrary.
That would be a long, drawn-out history lesson that would be hilarious. Maybe some point in the future we can go through all of that, because a lot of it is just idiotic.
Metrology beyond SI units is a very storied, strange history. I think especially when they first started kind of wanting to define measurements in such a defined way, that they don't change anytime. Really took place during a time where you had length being measured by stupid means like the length of an archduke's foot or crap like that. So that kind of sprung us into where we are now. But finally, the kilogram is getting its moment in the sun. Now, with that definition of the kilogram in mind, that international prototype of the kilogram cylinder, also known as Le Grand K, was forged in 1879 and is held in a locked vault where it has remained. Now, all replicas are based on that prototype of Le Grand K, but on this Friday, the International General Conference on Weights and Measures will meet in Versailles, France, to vote on whether to redefine the kilogram, and that vote is expected to be unanimous. So going forward, the world system of mass measurement will not be based on some special hunk of metal, but rather an unalterable feature of the universe, just like its other 6 SI-based unit brethren. Now, the National Institute of Standards and Technology here in the United States, specifically in Maryland, specializes in the science of measurement and holds a pair of official duplicate squat metal cylinders in a secure, climate-controlled lab, each one under 2 old-fashioned glass bell jars. So imagine the rose from Beauty and the Beast, but instead of a rose, it is a metal cylinder with a larger glass bell jar placed over it.
Mm-hmm.
Yep. Look a picture up. It's exactly how I described it. Anyway, but those
rather silly looking.
Yeah, I don't know. You'd think they'd come up with a better, more vacuumed way to keep it, but no.
Yeah, people like to look at things like that in museums or something.
Even the method of storing it is outdated.
Oh yeah.
But anyway, but those are our national standard kilograms, those 2 replica cylinders. And those are what we use for the basis of our mass dissemination systems in the United States. And they're used to calibrate and precisely measure instruments used in various purposes like research, measurement labs, pharmaceuticals, even things as big as airplane manufacturers. Now, the nation's official kilograms are so precious to us that no one touches them, not even with gloves. Instead, the metal artifacts, I will call them, because it's kind of what they are now. They're also pretty old too. I think these were given to us in like the late 1800s.
Yeah.
But instead, these metal artifacts are carefully picked up with a special tool wrapped in filter paper to avoid leaving any tiny scratches or fingerprints that could throw off the weight of the cylinder. And therein lies the big problem with basing a measurement system on the comparison of a piece of metal. If the Grand K gets heavier or lighter, the definition of the kilogram literally changes. And scientists believe that something like that has been happening because Le Grand K seems to now weigh slightly less than the official copies it's produced. So how are you supposed to accurately measure something's mass when your basis for mass keeps changing? And that is exactly why they will be voting to redefine it at this meeting this Friday. Now, what is this new definition, you may ask? Good question. The new definition will be the fixed numerical value of the Planck constant H to be 6.6207015 times 10 to the negative 34th when expressed in the unit kilogram meter squared per second. Now, the way they measure this is actually less complex and fairly cool. They use a tool called a Kibble balance, which that National Institute of Standards, forgot the full title of it. I have it somewhere. National Institute of Standards and Technology has one of these that they built and completed in 2015. It sounds like a simple instrument based on how I'm going to describe it to you, but if you look at a picture of this actual thing, it's far from it. So basically, very oversimplifying this, it has two modes. It has a weighing mode and a velocity mode, which is important in the calculation. In weighing mode, you have a wheel that is attached to a platform where you put your mass. And under that mass is a coil of wire. And that will be lowered into a magnet. So you have a huge magnetic ring. There's a coil. Attached to that coil is a platform with mass on it. And that is hanging on to some kind of strap that is spooled over a wheel. Now, and when in this weighing mode, the upward force on the coil is the product of the current in the coil, the magnetic field strength of the magnet, and the length of the wire of the coil. So you have your current I, your magnetic field strength B, and your length of wire L. And it exactly equals the weight, which would be your mass times gravity, which is what weight is. Mass and weight are not the same thing.
Oh.
And that test equally weighs the weight of the test mass. So what you end up having formula-wise is that mass times gravity will equal current times the magnetic field times the length of the coiled wire. When in the velocity mode, the voltage induced in the coil as it moves equals the velocity times the magnetic field and the coil length. So mathematically speaking, if you take those two formulas, so we have mass times gravity equals current times magnetic field times length. That's your weighing mode. Velocity mode, you have the voltage equals velocity times the magnetic field times the coil length. So you'll notice there they have two very key things in common. The magnetic field and coil length will be the same in every case, so they cancel out. So what you're left with then is you have that magnetic length and coil will be equal to mass times gravity divided by current, which will also equal the voltage over the velocity. And that's how you get your mass. So in other words, you'll have watts on one side, which is current times voltage, equals mass times gravity times velocity, which is watts of mechanical power. And that little m there is now our kilogram. And that, my friends, is how we have our new definition of the kilogram.
Raucous applause erupts.
Thank you. Thank you. You're probably like, why is this dude explaining math over? It's not that hard, okay? Rewind
It's not.
it. Pause.
It's very simple, honestly, compared to some things that I've run into myself.
Right.
Not calculus, which is good.
Here's the thing, when you're dealing with something that has to be so precise too, is that while the equations written are very simple, the numbers you're going to get from actually measuring this stuff have to be so specific, because you're measuring the base unit. And they're measuring the mass of one of those cylinders. That's how they're ending up with this as well. So they assume Planck's constant, and that's what they're rolling with for the definition of the kilogram. Pretty cool stuff. And maybe one day I'll do some segment about the ridiculousness and the history of metrology, which is the study of measurements, for those of you who do not know and would like to get some points in potential trivia games. You're welcome. We do provide some trivia help from week to week, whether you know it or not.
A little bit.
A little bit.
Just a little bit.
Wow. That went faster than I thought. I thought it was going to run out of stuff.
Well, are we approaching end time?
We're about an hour and a minute in, so I'd say so.
Probably, yeah.
So we have a plethora of topics to make a title out of.
Do. This will probably be one of those weeks where it's a pain in the ass to think of one.
Yeah, so let's eliminate some things here. Like, I feel like we've done a particle-based title before.
Yeah.
I don't want to use something that we're gonna, we've done a lot of space-based ones as well. Haven't really done any medical or see your stories. I'm like, the things you talked about, I'm like, wait, I'm noticing a theme. We've already done those as titles, so it's gonna seem like I'm singling you out, but I'm not. It's just how it is.
High quality kibbles and bits.
Kibbles and bits. We didn't talk about bits.
We talked about kibbles and we talked about reproductive bits.
That is going to send such a mixed message for anyone who sees that title.
Well,
we didn't talk about dogs.
True.
But
it also could bring in new viewership.
Boy, they're going to come to the end of this episode and be like, huh? I feel betrayed.
If they made it through the rest of it, that is.
Oh, yeah, they probably fell asleep at that first bit about
why are there no dogs? Where are the dogs?
Abiogenesis. I wouldn't be surprised. Okay. I'll allow it.
Okay.
So
if it works, we'll go with it.
Indeed. So we'll be off next week.
Thanksgiving holiday, after all.
Yes. And then we'll come back the following week. And I'm sure we'll have something to talk about. We'll come up with something.
Whether it's politics or, I would assume at that point we'll probably have some political,
maybe
something or other to talk about.
Maybe. Who knows?
Who knows? Maybe they'll actually have all of the votes counted in particular
yeah.
midterm races by then.
There's still a surprising amount not called yet.
Yeah. Ongoing effort there.
Jeez.
But we don't need to talk about that now because we need to end.
Well, we both hope you have a very high quality Thanksgiving. Not too many arguments with any of your unlike-minded family members.
Or maybe you're lucky and you don't have that happen during Thanksgiving, but odds are low.
And, enjoy some food. Maybe save your cheat meal for the month just for Thanksgiving Day.
Mm.
And yeah, I guess that does it for High Quality Podcast Action. I have been Nick.
I'm still John.
And you have High Quality Thanksgiving. Bye-bye.
Bye.